Good afternoon, everyone. So, I think in the last lecture, we have seen how to find out the transformation. First, we have found out the rotation through an angle phi, on which we are going to fix out z-axis, that is z is equal to z1. And then we have performed a rotation through an angle theta, and then we have fixed out x1 axis, that means x1 is equal to x2. And next, we have found psi, that is, we have again found that rotation is through an angle psi and it is rotated about z2. That means z2 axis is equals to z3. Right. First xyz has been changed to x1 y1 z1, in which z1 is nothing but z. That means fixing a z axis we have performed a rotation. Then it is x2 y2 z2, considering that we have fixed out x2, that is x2 is equals to x1. Next, we have changed it to x3, y3, z3. That is nothing but your x dash, y dash, z dash. Finally, we have found the transformation from x by z to x dash, y dash, z dash. Okay. What was our aim? Well, the question we have started with, we have to define Eulerian angles. After defining Eulerian angles, find the rotation through three successive angles and then find the common rotation matrix. Okay, we have to multiply all those matrices. I think those who have seen the recorded lecture, they can answer me. What was the question I have asked you in the last recorded lecture? Yes, anyone remember what was the question I asked you in the last recorded lecture? I told you multiplication of matrices B, C, D. Yes or no? Okay, first one was, say these are x, y, z. Z is fixed out to z1, y changes to y1, x changes to x1. Right, this is what an angle is phi. Next we have found is the matrix of rotation. I will write down for this example or for this rotation. As it is through z-axis, so it 0, 0, 1, last columns are fixed out, c cos phi, sin phi, minus sin phi, cos phi. Next, we have performed the rotation through an angle theta about the x1 axis. What was the figure that I have drawn you? Here was our z is equal to z1 and z1 is now changed to z2 through an angle theta. And next here we have, this is say y axis, this is y1 and say here is y2. This is through an angle theta, this is angle phi, and here we can have, this is x axis. Say this is x1 is equal to x2, this is what a rotation through an angle phi, and in the next rotation x1 is equals to x2. And here we have to write down the matrix which we have obtained for the second rotation is, as the rotation is through and we are fixing the x-axis, so these are fixed out, that is first row and first column is 1, 0, 0 cos theta, sin theta, minus sin theta, cos theta. Right. Next one, we have found the rotation through about z2 axis, that means z2 is fixed out. If you fix the z2, we have this is our y-axis, this is y1, this is y2, say this is y3, and here we have z is equal to z1. Next it is z2, which is equal to z3, which is equal to z dash. Here we have x-axis. This is x1 is equal to x2. Next one. Here angle is phi. Next angle we have found it is x3 is equals to x dash. This is through an angle psi. This is phi, angle theta and psi, and this is through an angle theta. Okay. So this was a figure, and here we have found the rotation about z2 axis. As it is about z axis, the last row and last column is fixed row 0, 0, 1, and the corresponding changes cos psi, sin psi, minus sin psi, cos psi. Okay, anyone having any type of a doubt, you can ask me. Hello, आवाज येत आहे माझा?
Yes, ma'am.
Okay, any doubt? If you're not having doubt, should we go for the next?
Yes, ma'am.
Okay, what was our job? We have to find out the common matrix, that is B, C, D. We have found from x to x1, that was our matrix D. x2 is equals to C into x1. Then we have found x3, which is nothing but your x dash is equal to x3 is equal to b into x2. Now we have to find out this x3, we have to put it as b. What is the value of x2? We have to put here x2 जो value थे कार put up करना c into x1, right? So here we get bc x1. What is the value of x1 from here? We have to put here b into x now. So here we get b c d. X1 value is d into x, right? From here I have to take this d into x1. And next, here we get this is x3 is nothing but x dash, and hence we get x dash is equal to b c d into x. Okay. So here we got the transformation from x to x dash. Now simply we have to find out the multiplication of all these matrices, that is b into c into d. Okay, this was a question for you to solve this. I don't know how many of you solved it and how many of you would see the recorded lecture. A is equal to b into c into d was a question to solve. This was not so much difficult to find out. No, simply we have to find out the multiplication of matrices. As it was a homework for you people, I am not going to solve it. Simply you have to write it and you have to multiply the matrices. What is a matrix B? I will write here cos psi, sin psi, 0, 0, 1, 0, 0, 1, since it is a rotation. As we are fixing the z-axis, minus sin psi, cos psi. And here it is 1, 0, 0 is cos theta, sin theta, minus sin theta, cos theta. Next is cos phi, sin phi, minus sin phi, cos phi. 0, 0, 1. Okay. So this we have to multiply. If you want to multiply, if you want to find out the answer, multiply these, and I will write the direct answer for this one. You have to multiply and you have to cross check the answer. Cos phi minus sin phi cos theta, sin phi minus sin psi cos psi minus sin phi cos theta cos psi. Last is sin theta, sin phi cos psi cos sin theta, sin phi minus cos theta plus cos theta, sin phi cos psi minus sine phi plus cos phi cos theta cos psi minus sine theta cos phi, and the last column I will write here sine theta sine phi 3 sine phi sine theta cos psi cos theta. Okay. This is first column, second and third one. I hope you are going to solve it. And this is what a matrix we have obtained. And this is a matrix which we have to write down x is equals to a into x dash. This a is nothing but b into c into d. So here we have found the transformation from x to x dash. Now we know that as it is an orthogonal matrix, how to check whether it is an orthogonal matrix? We have to check orthogonality condition. That means, but if you take any row or column, if you multiply, it will should be equal to 0, right? If you take any row or column and if you want to multiply, what you get the resultant cosine to sine psi minus, and this is plus. This will be equal to 0 plus or minus 0 into 0. It is again 0, right? And if you take the square, cos square plus sine square plus 0 square, cos square plus sine square is 1. If you take the square of these term, it should be equal to 1. And if you multiply the corresponding rows, or in another way, if you multiply the corresponding column, it should be equal to 0. माहिती है ना ऑर्थोगोनल मैट्रिक्स की प्रॉपर्टी?
Yes, ma'am.
Okay. So now we have seen in the last 2 to 3 lecture that whatever for orthogonality condition we have a dash, that is a dash is nothing but your a transpose is nothing but your a inverse in case of orthogonal matrix. Now what was the question? Initially we have first we have to find define Eulerian angle, find the matrix. After finding the matrix, here we have found the matrix. That means now we have to find out the inverse. Okay, how to find out inverse? With the help of this condition. If you remember, we have proved one thing that for orthogonal matrix, A inverse is nothing but A dash, and in the next we have proved A dash is nothing but A transpose. आठवते का कुणाला? We have proved the for orthogonal matrix A inverse is nothing but A dash. That is inverse is identified by A dash and A dash is nothing but A transpose. These two theorems we have proved continuously in the last 2 to 3 lectures, and after that now we have to find out what is A dash. What will be A dash? It is nothing but B into C into D. It's a dash which is nothing but D dash, C dash, B dash. Correct, na? This is a property of a matrix. Now, what is D dash? D dash is nothing but D inverse, right? Because all are orthogonal matrix. Huh? We can write here this B, C, D, this B. For this, we can write it as B dash is nothing but B inverse, which is nothing but B transpose. And here we can write this as the C dash is nothing but C inverse, and which is nothing but C transpose, and for similarly D dash is nothing but D inverse, correct? So here I can write it as C inverse B inverse. Now again using the property of a matrices, I can write this as B C D. Its whole inverse is nothing but D inverse, C inverse and B inverse, correct? What is this BCD? This is nothing but your A. It's a inverse, and hence we get E dash is equals to A inverse, and which implies that A dash is nothing but A inverse, which means that it is A transpose by orthogonality condition theorem, and hence we can write A inverse is equal to, what you have to do now, we have to change the rows to column. हे जे matrix आहे ना, this small matrix whatever we have found, for this small matrix we have to write down the inverse. For writing the inverse, we have to just change rows to column. Okay, any doubt for this?
No, ma'am.
Okay, now if well, let us go for the next one, that is angular momentum. Of a rigid body. rigid body. What was the question about obtain the angular momentum of a rigid body about a fixed point of the body? Then the body rotates instantaneously with the angular velocity omega in terms of inertia tensor, right? We have to find out the angular momentum of a rigid body when a body is fixed out. Okay? We have to fix a body at some position. Say this is what a position O, and this is what a rigid body. Here we have to find out a angular momentum of this rigid body. Suppose this is what a line passing through this region, which we have fixed out. Now suppose this is say velocity, and suppose here is some position with sorry this is uh, what velocity vi, and say this is what a position vector ri, and here we can have the angular momentum omega. Okay, for the last one, I want to ask you what was our question? We have to find out the transformation between the space set of axes and body set of axes. So, what was our body set of axes? These are x dash, y dash, and z dash, and x, y, z are space set of axes. What is space set of axes? These are fixed in the space. X dash, y dash, z dash means they are fixed in the body. So here, this is what a body here. After having a rotation, we have x1, y1, z1, and here we have x2, y2, and z2, and here we have x3, y3, and z3. So in the last example, for the last theorem, we have found the transformation from space set of axes to body set of axes. Okay. Now here what we have to do, we have to find out the angular momentum. If we are going to fix out a rigid body at some position, say oh this is a position vector, and suppose this is a velocity. And now consider a rigid body consisting of n particles. Suppose it has consisting of n particle with the masses mi. Suppose this is m1, m2, and so on, rotating with angular velocity omega. That means the angular velocity is omega for this body. That means if I am going to fix out a one point on the rigid body, then translation motion is absent. This we have studied. If you are fixing a one point on the body, translation motion is absent, so it will rotate, right? Fixing this axis. Just like flag, झंडा होता है ना? So we about this axis, this body will rotate. Rotating with an angular velocity omega, take one point of the rigid body is fixed, translation motion is absent, then the body rotates about an axis passing through the fixed point. Right. So here this is what a velocity, linear velocity of the ith particle, and Ri is a position vector of ith particle. And then we can write down the relation between the linear velocity, position vector, and the angular velocity, which is given by as I don't know how many of you remember from the physics. We have this relation that this angular velocity, this is what angular velocity, linear velocity, and the position vector. Okay. Uh, Here we can say that this is what a relation between the angular velocity, position vector, and linear velocity. By using this relation, now what is L? L is the angular momentum. I hope you remember in the basic lecture I have told you what is L. L is a angular momentum, which is the sum of all the momentum acting on each and every particle, right? What is Li then? Angular momentum of ith particle. Li is angular momentum of ith particle. Angular momentum of ith particle, and this is given by L is equals to summation over I runs from 1 to n. Because we have considered as n particle which consisting of mass say m1, m2 up to mn, and I is a ith particle, Ri is a position vector of ith particle, and now we can write L is nothing but Ri cross Pi. If you remember from the first lecture or the lecture which we have taken for the basic points in the classical mechanic, at that time I have given these formulas. What is the relation between angular momentum, linear momentum, angular velocity, right? So what is this P is nothing but your linear momentum, and how it is given by, it is nothing but mass into velocity, correct? Got it?
Yes, ma'am.
Hmm. Now, if mass is independent of this, so I can take outside. Mass is a constant term, so I can take outside, and V remains with simply Ri cross Vi. Now we have to use a equation 1. What is our equation 1? That is a relation between linear velocity and angular velocity, which we can write here. It is W cross Ri. Instead of this Vi, I can write this is W cross Ri. This is what L is equals to. This is total angular momentum, which is sum of all the angular momentum acting on each and every particle. Okay, Ri cross, this is what W cross Ri. This is saved 2, and we can say from equation 1 we have written this. And now Ri is a position vector of a particle. If, let me write down this. Ri can be written as xii plus yij plus zi. Okay. What is W? W is a angular momentum, which I can write wxi plus wyj plus wz. Okay. By using the property of vector triple product. What is the property of a vector triple product? Which we have written like this: A cross B cross C. Right. I think you knowing about A dot B cross C. A dot B cross C. You are knowing about this, but what is the relation if you have A cross B cross C? Because we have to work this here, right? This is what, suppose it is A, B, and C. We have to find out the cross product of these vectors Ri, W, and Ri again, right? For that, I don't know how many of you remember this A cross B cross C, which we have studied in the 12th standard. A cross B cross C is nothing but B dot C dot A minus C dot A dot B. Okay, this is BCA minus CAB. That is A cross B cross C can be written as B dot C dot A minus C dot A dot D. Okay, what is this one? I can write this as, suppose the cycle is completed like this is what A, oh, vector A, this is B, and this is C. Okay, so A cross B cross C can be written as B cross C cross A, and then C cross A cross B, sorry, C dot A dot B. Okay, so by using this cross product property of a triple cross product, we have to use this in equation 2. You can say using this in equation 2, we get, what we get is L is equals to summation over I. This mi is outside. I runs from 1 to n, and here now we have to check what is A cross B cross C. Now let me check what are the values of A, B, C. Here we have Ri, W, Ri. That means one vector is repeated here, right? So this is what Ri, W cross Ri, correct? याच्यात आपल्याला काढायचे ना क्रॉस प्रोडक्ट ऑफ ट्रिपल क्रॉस प्रोडक्ट. So this, what is B? B is nothing but your this one W. W dot, right? After W, what we have? C into A. That C is nothing but Ri into Ri. That is Ri square I can make. Okay? Are you getting?
Yes, ma'am.
What is C here? In this case again, C is Ri. A dot B. What is our A? A is nothing but your Ri into W. And we have to use here this. Okay, let me write down as it is whatever I have written. This is W dot Ri square minus Ri dot W. So in terms of components of the vector involved in this equation, we can write it as, now we are writing this in terms of component. How to write in terms of component? This is Lxi, Lyj plus Lzk. That means we are writing this as this is a angular momentum acting on whole body. So this is angular momentum acting on whole body can be written in the terms of angular momentum acting in the direction of x-axis, angular momentum acting in the direction of y-axis, and angular momentum acting in the direction of a z-axis, which is equal to, now I can write this as summation over I runs from 1 to n mi. Now this w can be written as wxi plus wyj plus wzk into ri square. This ri square as it is minus, now what is a ri? Here I can write this is, because ri square we know it is x square plus y square plus z square. I can write this is xii yij plus zi. About this one I am writing. In the next is dot product with ri dot w. For that I will write directly the product of these two. I dot I is 1, I dot j is 0. Okay, I have to multiply this with this. Ri dot w. Are you getting ri dot w? You have to multiply these two. This is w, this is ri. Okay, I dot I is 1, all I dot j will be 0, right? Why I dot j is 0? Because of the properties of dot product, right? Why I dot j is 0? Because angle between I and j vector. What is I? This is a vector, unit vector in the direction of x-axis, and j is a unit vector in the direction of a y-axis. So the dot product between x and y-axis is obviously 0. Why it is 0? Because a dot b can be written as mod a mod b cos of theta, angle between the two vectors. Now I have to multiply these two, which will be equal to wx xi plus wy yi plus wz zi. Okay, I will complete the bracket here. Are you getting? Is there any doubt up to this step?
No, ma'am.
Okay, now simply I have to multiply these and we have to write this one. This is what Lxi, Llyj and Lzk is equals to summation over I tends from 1 to n mi. I have to multiply this. This will be a wx ri square into I plus wy ri square j plus wzk wzri square into k. Okay, we have written simply multiplication of these two terms. Okay, this is what wx, wy, wz and multiplication with ri square, this I have written here. Now I have to multiply the next terms with the negative sign. Okay, this one here minus, this is common for the whole bracket, minus what we have I as it is xi into wx, xi dot xi will be xi square plus next term we have to multiply these two, we get it is wy xi yi into I. Okay, plus wz xi zi into I. Write the I plus what is the next term? We have to multiply this yij with all this term. डॉट प्रोडक्ट येते ना आपल्याला मल्टिप्लाय करायला. दिस इज जे वाय आय एक्स आय डब्ल्यू एक्स प्लस नेक्स्ट टर्म इज वाय आय जे डब्ल्यू वाय yi square plus next term this j as it is wz yi zi plus next is zi xi k as it is. Last term I am multiplying, this is wx plus zi this k outside wy yi plus wz as it is k outside and zi into zi that will be zi square. Now this square bracket completed and the curly bracket because mi is common for all. Okay. Now what we have to do, we have to collect the common terms in such a way that we can write the simplifications. Okay. Writing the simplification, first we will collect the coefficient with wx, wy and wz. Okay. What are the coefficients of wx? Okay. Here you can see this is wx, here is also wx. The coefficients of wx, after that coefficient of wy, then coefficients of wz. Okay. So in this way, I will write this directly so that you can understand by taking the coefficients I, j, k common. This is I, and wherever I you have, this is I, here is also I. So wherever you have I common, we have to take I common and we have to multiply that mi inside, and then we can write this as I if I take common. So what we means is wx if I take common, this is summation over I. Mi was outside and now I can take it inside. If wx is common, if mi is also common, we remains with ri dot square minus xi square minus wy summation over I mi xi yi, right, minus wz summation over I mi xi zi. As I am wz I am writing outside since it is independent of summation over I. Next I will collect the coefficients of j. Coefficients of j, j is taken outside and here we have wy summation over I mi ri square minus yi square minus wx summation over I mi xi yi minus wz summation over I mi yi zi, right, plus next we have to write down the coefficients of that is taking k common, we have this is wz summation over I mi ri square minus zi square minus wx summation over I mi xi zi minus wy summation over I mi yi zi square. Okay. Completing all this, what we have to do, we have to simply take the coefficients I common. Here is I, here is also I, here is also I. So we have to collect the coefficient with I, coefficient with j and z, j and k. Completing this, we have to again combine this. If wx is common, then you have to write this as wx common, wy common, and wz common. Okay, any doubt up to this one? आहेत का जागे?
Yes,
Hello.
ma'am. Yes, ma'am.
Okay. Now we can write this as Lx. What we have here, Lxi plus Lyj plus Lzk. Why we have written this? This is written in terms of component. This is simply a vector L. This is angular momentum, which is equal to I is common. This I will write it as Wx Ixx. Now, whatever the terms we have written, we will write them in a compact form. We will denote them as Ixx. Okay. Whatever this term we have, this whole term we will name it as Ixx because here we have xi square. So hence we will name it as Ixx. Later on, I will show you what is a formula for I. If you remember moment of inertia, आठवत का moment of inertia? What is the formula for moment of inertia?
Mass into distance.
Mass into distance square is a moment of inertia. Okay, moment of inertia was denoted by I. If you remember that in the 12th standard we have written many times this formula. I is equal to mr square. Okay, here also we have in a very similar way m into ri square minus xy square. This I will denote it as capital Ixx. And here we have xy. This is ixy, ixz. Okay, iyz. Like this I am going to denote. This is what iyy. And the last one, this is IZZ, IXZ, and IYZ. Okay. So by using the formula of moment of inertia, I will write all this as IXS plus WY IXY plus WZ IXZ, right? Plus we'll collect uh, taking the J common, that is coefficients of J are WY I yx plus wy iyy plus wz iyz plus k times wx izx plus wy izzy plus wz okay. After comparing the coefficients of ijk, here is also ijk, no? After comparing the coefficients of ijk, we can write this as Lx is equals to Wx Ixx plus Wy Ixy plus Wz Ixz. Similarly, we can write for Ly is equal to Wx Iyx plus Wy Iyy plus Wz Iyz. This is what comparing the coefficients of ijk we are writing Lx, Ly, Lz. Okay, now simply we have to denote that what is Ixx, Iyz and all. Now we have got these three equations. Now these three equations I have to write in the form of a matrix. What is a matrix for this? I can write this is L into I into W. And hence we can write this is what your Lx, Ly, Lz, right? And what will be I? I is this 3 cross 3 matrix, and here we have simply Wx, Wy, Wz. And here in this we can have Ixx, Ixy, Ixz, next Iyz, Iyy, Iyz. Next here we have Izx, Izy, and the last is Izz. Okay, so then we have written this in terms of L is equals to I omega. So hence we have found the angular momentum, that is L is equals to I into omega. Angular momentum we have found now in terms of angular velocity. Okay, Any doubt?
No, ma'am.
No doubt the proof is very large, but you have to remember this. What you have to do? Simply we have to use this formula. What is the relation between linear velocity and angular velocity? After that, the angular momentum you have to find out. Angular momentum is a summation of all the angular momentum acting on each and every body. And then we have used a formula for angular momentum is nothing but Ri cross Pi. After using Ri cross Pi, we know the formula for the linear momentum is mass into velocity. And after using this, we have the formula for velocity in terms of angular momentum, angular velocities, W into Ri, which we have to use here using equation 1. And after that, we have to use a triple product. Cross product, that is A cross B cross C, is B dot C dot A minus C dot A dot B. So what is our A? Ri. B is W and C is Ri. So one vector is repeating here, and hence we get this relation. Using this in our equation 2, we have this term. Now simply we have to multiply. After multiplying, we have to collect the coefficients. That is, here we have Lxi, Ly and Lz. Okay, so we are going to collect them as ijk only. Okay, so that if you collect the coefficients of ijk, then you can write this, comparing the coefficients of ijk, we can write it as Lx, Ly and Z is equal to, and then we can write this in the form of a matrix, that is L is equals to I into omega. Okay, so if I am going to start the next proof, it is also much more larger. That is kinetic energy of a rigid body. We have to find out. This we will take in the next lecture, and we are remaining with only 4 to 5 lecture. After 4 to 5 lecture, we will complete our syllabus of classical mechanics. Start with your study. Do your study. Complete your syllabus. At least you have to write it once so that you can answer every MCQ question. While giving the exam, you cannot search for your notes. Notes में जाके search नहीं कर सकते ना. So at least you should read it once and write it once without looking, and then you can give the exam very easily. Okay. शोधण्यासाठी आपल्याला माहित पाहिजे ना ते आन्सर कुठे आहे. Okay, so be ready with the exam because only 5 lectures are remaining if for completion of syllabus of classical mechanics. And after that also, if you have any type of a doubt, we will take one more lecture to have a discussion on the doubts. Okay. Because I am not starting the next proof because it will take again much more time. So we'll stop the lecture here, and your practical will be starting maybe tomorrow or day after tomorrow. We'll tell you what is a schedule for practical sessions. 10 practical will be conducted, and in for every practical we will give what we will take in that practical session. Okay, thank you. You can